Welcome to Chapter 2 on integers. In this lecture, we are going to talk about multiplying and dividing integers, adding integers, subtracting integers. We're going to go through a few definitions, use the distributive law, and finish up by solving two-step equations. Now, what are integers? Integers is the set of positive and negative whole numbers. So we've only dealt with whole numbers in the last week, but now we're going to add the negative numbers as well. And that's what we're covering for this week. There are two main things that you need to remember when multiplying or dividing integers. The first is that if you're multiplying two numbers and the signs are matching, meaning they're both positive or they're both negative, this is a good thing. And if it's a good thing, it means that your result is going to be positive. However, if you have a mismatch of signs, one is being positive and one is negative in either order, that's not a good thing. That's a bad thing, and so the result is going to be negative. So for every two negative numbers, your result ends up being positive, which means that if you have a bunch of numbers together, say you're multiplying 3 or 4 or 5 or 6 numbers, you can just count the number of negatives you have. If you have an even number of negatives, that would mean that we would have an even number of pairs of negatives. And we said before that a pair or two of the same sign is positive. So if you have an even number of negatives, your answer will be positive. And similarly, if you have an odd number of negatives, then your answer is going to be negative because you're going to have a grouping of two or a pair of negatives, which will make it positive, but that odd number is that odd man out, and that's going to make your final result negative. So simply put, when multiplying, if you have a positive times a positive, it's a positive, and a negative times a negative is a positive. So two of the same signs, that's the good thing. That's how you end up with those positive responses. However, if you have a negative times a positive or a positive times a negative, remember the order of multiplication doesn't matter. Whether the negative is first or second, your result will still stay the same. And in this case, it's going to be a negative result. The exact same thing happens for dividing because dividing is the same thing as a multiplication problem. And we'll get into that more as the chapter goes on, or as the chapters proceed, and we get into some fractions. But since dividing is the same thing, you have your same rules. Now remember, we write our division as a fraction. It's a positive divided by a positive, or a negative divided by a negative. Both will result in a positive response. Similarly with the multiplying though, if you have one of each, whether it's a negative on top and a positive on the bottom, or vice versa, your result will be a negative number. Let's look at a couple of examples. Our first example here has a -6 times a -5. Now, as we are getting into our algebraic notation, remember this is a pre-algebra class, so we want to make sure that we're using our algebraic notations and not the arithmetic notations that we learned when we were kids. So here it says -6 times -50, and I know that because the -50 is in parentheses. That's right next to my -6. And so that it indicates an operation for us. Those two numbers being mushed together with those parentheses indicates multiplication. So that says -6 times a -50. We have a negative times a negative. They match. There's two of them. So that my result will be a positive 300. In the second example, we have a -25 times an 8. A negative times a positive, one of each, means that we have a mismatch, which that's a bad thing, so my result will be negative. And if I had 8 quarters in my pocket, I'd have $2, so that's 200. Now if we had more than two numbers being multiplied together, we can do a problem like that as well. If I have a -7 times a -4 times a -1. Once again, this kind of goes to that second set that I had that said, hey, if I have an even number of negatives, my answer is positive. If I have an odd number of negatives, my answer is negative. So you can count your negatives. We have 1 negative, 2 negative, 3 negatives. That's an odd number, and so my result will be negative. Now when I do my multiplication, I can actually ignore the negatives and just multiply 7 times 4, which is 28, and take that 28 times 1, which is still going to be 28. So my result is a negative 28. We can do the exact same thing for this other example and say, okay, what if I had negative 2 times negative 5 times negative 3 times negative 5? Once again, we're putting the numbers in parentheses to indicate multiplication. Now you may have noticed that in this first one up here, I didn't put the negative 25 in parentheses, but I am putting the negative 7, and in this new example, the negative 2, that leading number, in parentheses. It doesn't matter, you can put it in parentheses or you don't have to. I kind of like to put my negatives in parentheses to remind myself that they're there, but it doesn't have to be in parentheses in your first number. It still is indicating multiplication because of the parentheses after. So once again, because I have so many different numbers that I'm multiplying here, and I have some that are negatives, I want to find out how many I have. So I just count. 1, 2, 3, 4, 4 negatives. That's an even number of negatives, which is going to be a positive result, because for every 2 numbers that you multiply that are negative, you get a positive. So negative 2 times a negative 5 would be a positive 10. And if I multiply the negative 3 times the negative 5, I get a positive 15. So now I have 2 positives that are multiplying together, which is exactly what we have, a positive 154 result. That's why every 2 negatives make a positive, so if I have an even number of negatives, my answer will be positive. To add integers, we need to make sure that we can use some tools out there so that we are able to apply those tools to problems that we already know how to do, like 4 plus 7, to ones that we might not know how to do because they have negatives involved. So if you just think about the problem 4 plus 7, how would I add this on a number line? And the way that we would do that is we first put ourselves on the first number. So here's 4, so here I am on 4. And now I move in the positive direction, because I'm adding to that, 7 steps. So that means I'm heading this direction, so I'll put my good 80s hair on. And I'm heading in that direction. And I take 7 steps. 1, 2, 3, 4, 5, 6, 7. Okay. And my end result is here at the number 11. So 4 plus 7 is 11. Okay. So if I do the same type of problem with a negative, how is that going to change things? How will that affect it? Well, here I'm still starting on the number 4. Here I am. I'm adding to that, so I'm still looking towards the positive direction. But this time I'm not going to move forward, I'm going to move in the opposite direction of what I'm facing. That opposite direction means I'm moonwalking or going backwards. So I go backwards 7 steps. 1, 2, 3, 4, 5, 6, 7. And here I end up at a negative 3. So if I had $4 and I take away $7, or I add a negative $7, I'm at negative $3. I'm in the hole. Right? Now, mathematically, what did we do there? Well, in the first problem, both of our signs were the same. It was a positive 4 and a positive 7. So we added the 2 numbers and kept it positive. In the second example, we had 1 positive number and 1 negative number. And essentially, the math that we did with a 7 and a 4 to get 3 is to subtract. So when I had 1 of each sign, I subtracted. Now, I started with the 7. If I saw 4 and 7, I would say 7 minus 4 in that case. That's how I would think of that mathematics. And because I started with the 7, my end result is going to have the same sign as what's on the 7. The 7 was negative, so my answer will be negative. Let's find a summary for that. We have just 2 rules for adding integers. The first one simply states if the numbers have the same signs, add the numbers and keep the sign. Like I said before, 4 plus 7 is 11. Similarly, if I had negative 4 and I was adding a negative 7, I put the negatives in parentheses just to remind myself that that number is negative. It does not mean multiplication here. You look in between the numbers, there's a plus sign, that's the operation. It's just to make sure that my negative here by the 7 doesn't get lost with the plus sign. But here they're both negative numbers, so I'm going to add the numbers and keep the sign. So a negative 4 plus a negative 7, a negative plus a negative is more negative because we are adding. Don't get that confused with our multiplication rules that we already applied. When multiplying two of the same number, that's a good thing, or a positive. But when adding two negatives, it makes it more negative. So you need to understand the different operations between multiplication and addition, and therefore the rules are different. You might want to write those down a few times to make sure that you practice them and you remember them correctly. So the adding rules are different than the multiplication rules. So a negative 4 plus a negative 7 is a negative 11. And just like we had before, 4 plus 7, those are both positive numbers, gives us a positive 7. So that's the first rule. If the numbers have the same signs, then add the then add the numbers and keep the sign. Well, what if the numbers don't have the same signs? If the numbers have opposite signs, meaning one is positive and one is negative, that's when we are going to subtract the numbers and then use the sign of the larger number. Now, why do I put larger in quotation marks? I put larger in quotation marks because a negative number is never larger than a positive number. A positive number is always the larger number. However, when I mean larger in this case, I mean the number that's further from 0. That's part of that absolute value that you, you read about in your textbook. The absolute value is the distance a number is from 0. Distances are always positive. So we want to find out the number that's further from 0 or has more steps and therefore is larger in that aspect. So in that case, we might have, if we had the 4 plus a negative 7, once again the 4 is positive, the 7 is negative, so we subtracted. 7's the larger number, or the one further from 0, so the sign goes with it. If I had instead negative 4 plus 7, the 4 is negative, the 7 is positive, so once again we have one of each sign, so we subtract them. When I see the numbers 4 and 7, I'm still going to take 7 minus 4 and get 3. Now I started with the 7, and this time the 7 is positive, so my result is positive. Let's practice a few more of those. Here are a few examples for adding integers. The first one, I have a negative 16 and I'm adding 6 to it. Well, if I was $16 in the hole and I added $6 to my checking account, I'm not as much in the hole, so I'm going to get closer to 0. That's one way of logically thinking through the problem. Here I notice that I have a negative and a positive. That means I'm going to subtract the two numbers. When I see a 16 and a 6, the way that I would subtract it is simply 16 minus 6. So that's how we start off, and that's how we're going to get our answer of 10. Now I started with the 16 in my mind when I did that subtraction. So wherever I start, that's the sign that goes with. $16 in the hole, adding $6, I'm still in the hole. So my answer there is a negative 10. The next problem, I have negative 17 plus a negative 7. This is the first rule that says if I'm adding two of the same signs, and they're both negative, and I'm adding, it means I add the numbers and keep the sign. 17 and 7 makes 24. In my next example, I have 14, so a positive 14, and I'm adding a negative 5. A positive 14 and a negative 5, one of each, so I subtract. If I had the numbers 14 and 5, I would subtract them. 14 minus 5. I start with a 14, which is positive, so my answer will be positive, and taking 5 from 14 gives me 9. Now this last example is a little bit trickier. It has more than one addition portion to it. Okay? But adding, it's all addition, and according to our properties of addition, our laws of addition, we can add whichever numbers together first that we want to, whichever order we want to do it in. Okay? The order does not matter when we are adding. That's called the commutative property of addition. So in this case, what I would do is I would say, well, the rule of adding numbers that have the same signs, I get to add. I like that. So I'm going to look to see, okay, do I have some numbers that have the same sign? And here I have a negative 17 and a negative 14 that I'm adding. Well, if adding two of the same sign, I add them and keep the sign. So when I add that, I get a negative 31. I'm going to add this other negative to that one. So I still have the 75 on top, plus negative 31 and a negative 5 is a negative 36. Same rule, adding two of the same sign, you add and keep the sign. And now I have it broken down to a positive 75 and a negative 36. One of each sign we subtract and keep the sign of the larger. 75 is larger or further from 0 than negative 36. So my answer is going to be positive, and I would subtract, and 36 from 75 is 39. So I added all of my like types of numbers together first. A negative plus a negative is more negative because I like to add as opposed to subtract. If I had more positive numbers besides just the 75, I would do that same procedure with all of the positive numbers, add them all together. So then my last step would be to have the total of positive numbers added to the total of negative numbers. So I would only have to do subtraction once. Subtraction has a different set of rules than adding. However, it gets a little complicated to remember all these different types of rules. So instead of remembering a different set of rules for subtracting, it's imperative that we look at the connection between adding and subtracting. Subtraction is a form of adding. It's called adding the negative, is what our subtraction actually is. So what we can do is, instead of learning new rules for subtracting, we're just going to learn how to change all of our subtraction problems into addition problems. Because we know that the two rules for addition are pretty easy. Either they both have the same signs and we add and keep the sign, or they have one of each sign and we subtract and keep the sign of the larger. So since we only have two addition rules, and they're pretty easy to remember if we rewrite them and recite them over and over, instead of remembering new rules for subtracting, let's just learn how to change subtraction into addition. Now, the reason that we can do this is actually because of our rules of multiplication. If you recall from our multiplication little rules, we had something like this that said, hey, a negative times a positive gives us the same result as a positive times a negative. Okay? It also lets us know that a positive and a negative give us the same results. It's this information that is actually going to help us with our subtraction. So in subtraction, what I'm going to do is implement what I call a change. Okay? It's always just a double change. Okay? The first change is changing the subtraction symbol to an addition symbol. But we can't just change subtraction to addition, because now you just change the value or the problem itself. So we have to do a second change to even it out. And the second change is to change the sign on the number right after the subtraction sign. So if it's a negative, I change it to a positive. If it's positive, I change it to a negative. So you just switch it. Why do we want to do the change? Well, if I do the change, the problem is now an addition problem. And we know the two addition rules. So you just apply whichever one fits. For example, here, I have that 4 minus 7. So I see that it's a subtraction problem. The 4 is positive. The 7 is positive that we are subtracting. So I'm going to do the change. Once again, the first change is changing the subtraction to addition. The second one is changing the sign on the number right after that. The 7 doesn't have a number or a sign in front of it, which indicates that it's a positive 7. So I'm going to change that to a negative. So 4 minus 7 is the same thing as 4 plus a negative 7. Now we have an addition problem, and we can apply the addition rules. Both numbers have opposite signs. One's positive, one's negative. So that means that we subtract and keep the sign of the larger. This larger number is the -7, as that's further from 0, and it's negative, so my answer will be negative. And then we subtract. 7 minus 4 is 3. So 4 take away 7 is -3. Let's go through a few more of those examples to make sure that we understand. The first one says 1 minus 9. Once again, it's a subtraction problem, so I'm going to make it into an addition. By the change. So the subtraction gets changed to an addition. The sign on the 9, there's nothing there, so it tells me it's positive, so I change that to a negative. So 1 minus 9 is the same thing as 1 plus a -9. Now that I see that it's a positive and a negative, we can subtract the two numbers and keep the sign of the larger. So it would be 9 minus 1. I started with the 9, which is negative, so my answer is negative, and 9 minus 1 is 8. So 1 minus 9 is a -8. Going onwards, if for this next one I have 8 minus a -10. Once again, do change. So I change the subtraction into an addition, and then the sign on the number after it is a negative, so I change that to a positive. So subtracting a negative is the same thing as adding a positive. That relates to those rules of multiplying also. A negative times a negative is the same thing as a positive times a positive. That's the connection. So then 8 plus 10, those both are positive numbers, so you add and keep the sign of positive. I have a couple more here. Next one is -5 minus a -2. Once again, change the subtraction to addition, and the sign on the number after is negative, so I make that into a positive. So this is the same thing as -5 plus 2. We don't put both positive signs. We use the plus sign, and then if there's no symbol on the 2, it's indicated that it's positive. So you don't need to put the plus sign to indicate a number being positive. You only need the negative sign to indicate that it's negative. Now we go through our addition rules. We have one of each sign since the 5 is negative and the 2 is positive, so we subtract. If I had a 5 and a 2 and I subtract, I would go 5 minus 2, which is 3, but I started with the 5. The 5 is negative, so my answer will be negative. One last one. If we have -18 minus 63, do the change again. The subtraction, not about the -18, it's about the subtraction changing to an addition, and then sign on the number right after it. So the 63 doesn't have anything, so we make it a negative. So -18 minus 63 is the same thing as -18 plus a -63. Both numbers have the same sign of negative, so we add the numbers and keep the sign. The idea is that after you do a number of these change with the subtraction, is that eventually you'll see the relationship between something like -18 plus the -63 and the -18 minus 63, so that you won't actually have to do the change. When you see it like this, you'll think of it in this fashion instead. You don't actually have to go through the procedure of change, but you'll know what that procedure is going to be. But don't feel like you have to be able to do that right away. Go through the change process, rewrite the problems if need be so that you can see it clearly, and go through your 2 addition rules. There are some key definitions in Chapter 2 that you need to start understanding, not only for this chapter, but for the entire course. The first one is, what is a term? This is one of the key components to any algebra class, is knowing what a term is. The other key component is understanding factors, which we'll get to next week. So terms, a term is simply a number, a variable, or a product of a number and a variable separated by addition. Could have more than one variable in it as well. Now, in order to understand the definition, though, we need to make sure that we understand the words in the definition, because if we don't understand that, the definition is lost to us. So a number, okay, we know what a number is. A variable, that's just another way of saying a letter. That's representing our unknown, or some number that we're not sure what it is. It's hidden, and we'll maybe find it, or maybe we won't. Maybe we're just playing with it as it is. Okay? Or a product of a number and a variable. A product, that is a key word in arithmetic. A product means the answer to a multiplication problem. Okay? Product means multiplication. So it has to be a multiplication of a number and a variable, or it could be variables, could be more than one, and those terms are separated by addition. So for example, if I had the number 12, that's a number, so that would be a term. If I had 12x, remember a number and a letter mushed together like that, right next to each other, means 12 times x. Times is multiplication, so 12x is a product of a number and a variable. Then I threw out, oh, how about 37x cubed y squared z? There's no addition signs or subtraction signs in there, it's all multiplication, and therefore that is one single term. It's an ugly one, but it's still one term. Then I have 14x plus 3. Now in this case, this is not a single term, this is two terms, because our terms are separated by addition. So the first term is 14x, that's the product of a number and a letter, but then we're adding, and so the first term ends, and then after your addition sign, your second term begins, and your second term is a 3. So there's two terms there, a 14x and a 3. My last example has 14x minus 3. This also is two terms. Well, wait, I thought terms were only separated by addition. Correct, but what did we just go through with subtraction? Subtraction is the same thing as adding a negative. So when I see this subtraction problem, I can think of change. So the first term is a 14x, and my second term is a negative 3. So the sign in front, which was a subtraction, makes that term negative. So the sign in front of the term goes with the term, if you don't want to do change. So the two terms on that one is a 14x, and the other term is a negative 3. Well, if I have 14x minus 3, why don't I get 11x? I don't get 11x because those two terms are not what we call like terms. Like terms are terms that have the same variable or letter, and the letter has to be raised to the same exponent or power. Power and exponent mean the same thing. So 4x and a 4, even though they both have 4s, are not like terms because this one has an x and this one does not. They have to have the same variable. 4x and 2x are like terms because they both have an x. So what do we need to know about like terms? Why does it matter if they are like or not? Because when it comes to like terms, we are only able to combine or add like terms. To combine or collect like terms, as your book might use, means that we add or subtract the number in front of the variable, but we don't change the variable at all. So in this problem with the 4x and the 2x, if this was adding, the 4x plus 2x are like terms, so we'd say 4 plus 2 is 6, and the x comes along for the ride. The variable does not change. If we're doing all that work to make sure that the variable and the exponent are the same, they will not change. Let's go through a few examples. In our first example, we have 5x and we're adding 8x. Once again, those are like terms because they both have x. That's the same letter, so we add the numbers in front. If I have 5x's and I'm adding 8x's, I'm going to have a total of 13x's. In the second one, I have 2x plus 6z plus 9x. Well, I can't add all of those because z is not the same thing as x. My like terms are the 2x and the 9x. We add those two together and get 11x, but we still need the 6z. That's one of the terms that's part of this problem. So it has to be part of the answer as well. So we're going to add that 6z to the end. Why to the end? because we like to keep our letters alphabetically, and X comes before Z. It's okay that you have these two terms as answers. You won't always get a single number for an answer when you're dealing with variables, and that's okay. That's one of our biggest hangups is we're so accustomed to, oh, it comes down to a single number. But that's not the case in algebra. When letters and numbers get mixed together, we might have what I call a little choo-choo train, the different train cars, and they're connected together by couplers, which are your addition or your subtraction signs. Okay? And that's okay in algebra whenever you're dealing with numbers and letters. How about this next one? Ooh, lots there. Once again, we should go alphabetically. And you start off with your the letters first and then the numbers at the end. So in this problem, the first thing I would say is T is my first one. So here's a T and here's a T. Remember, the sign in front of the term goes with the term. So it's a 5T and a negative T. A negative what T? What's in front of that T? What number is there? It's not a 0, because if we had a 0, 0 times T would be 0, and that whole T would not be there at all because it would vanish with the 0. So what do I take times T to get T back? Aha, 1. That's the god of Mathland. 1 times anything is anything. The 1 is often there. If we don't see a number, there's a 1 there. It's kind of like the god of Mathland. He, she, it is always there. We just might not see him, her, it. Okay? So I have 5T and I'm taking away a T. That's going to give me a positive 4T. Now my next term is going to be attached to this term by either a plus or a minus sign, depending on the problem. So we go through. Now my next term is going to have the y's, because that's the only other letter. I have a 7y positive and a negative y. Once again, that's a negative 1y. So 7y minus y ends up being a positive 6y. Now in this case, I need to put the plus sign because that's going to separate the term with the y with the term from the t. Those are two different terms and they need to be separated as such. Continuing on, we now only have our constant left, or this plain number. I have a 9 and I have a negative 13. The sign in front of the term goes with the term. Or if you want to, you can do your change and see that it's a negative 13. 9 and a negative 13, one of each sign. You subtract and keep the sign of the larger. The larger is 13 and that's negative, so I'm going to subtract. 13 minus 9 is 4. So I'm going to subtract the 4. You could put plus a negative 4, but at some point we want to go back to fewer symbols so that we're more prepared for our algebra class. We like to be succinct and thorough. So adding a negative is the same thing as that subtraction. We need to get comfortable with going both ways with that. This is your final answer. You cannot go any further with that because I cannot add a term with a T with a term with a Y, and I can't add either of those with a term that doesn't have a letter at all. This is your choo-choo train. You have a little passenger car, you have a little ex-hopper, and you have a caboose. And that's okay. Let's do one more. What if I had 8x squared plus 3y minus x squared? Once again, look for your like terms. X squared, 8x squared, and a negative x squared. Those both have x squared, so that's the same letter and the same exponent. Once again, the number in front, if there's nothing there, is a 1. So 8 minus 1 makes 7x squared. If I'm doing all that work to make sure that the variable and the exponent are the same, neither change when I add. And once again, just like in that second problem, we have this 3y that needs to be part of our choo-choo train at the end because it was part of our original problem. But there's nothing to add to it, so it just comes along for the ride. So your final answer there would be 7x squared plus 3y. The distributive law. Now this is going to help us out with our order of operations. We know from our order of operations that we went through last week that we would have to simplify anything inside parentheses first. After that, we look for any exponents. Then we do multiplication and division together, left to right, whichever one we see first. And finally, we do addition and subtraction. Once again, we do those together, left to right in the order that we see them. Well, what happens in this case if I have 2 times the quantity of x plus 3? If I simplify what's inside parentheses, I see I have x plus 3. Some unknown adding 3 is not the same thing as 3x. 3x means multiplication. Addition is not the same thing as multiplication. And as we just discussed before, we can only add terms that are alike. Like terms have the same variable to the same exponent. X has an x, 3 does not. So they do not have the same variable. So you cannot combine those. All right, so if I can't combine them, how can I get rid of my parentheses? Well, the second reason for parentheses is to indicate that this 2 is being multiplied to that quantity. This allows us to implement what's called the distributive law. The distributive law says if you have a number outside parentheses, that number gets distributed or multiplied to every term inside. Once again, we need to make sure that we understand what a term is so that we can follow the definition of the distributive law. Terms are numbers, variables, a product of a number or variable, separated by addition. Remembering also that subtraction is a form of adding. So to simplify this and get rid of our parentheses, we would take the 2 and distribute it or multiply it to the x. So we'd have 2 times x plus 2 times 3. Distribute it or multiply it to both terms inside. Now we wouldn't write it as 2.x plus 2.3. We can clean this up a little bit. When we have a number and a letter being multiplied together, we're allowed just to mush them together because we can tell the difference between a number and a letter and say that that must mean multiplication. Plus 2 times 3 we know as 6. So 2x plus 6 is your result for that expression. We're not solving anything, so it's not a solution. We just got rid of the parentheses by using the distributive law. We can do the exact same thing for this next problem. We have -4 times x minus 5. So you take the -4, the number outside the parenthesis, and distribute it or multiply it. -4x is written as such. Whoops. And -4, now here you have to be careful. Remember, the sign in front of the term goes with the term. So this is a -4 times a -5. But this is a separate term, so we need to make sure that we have either a plus or a minus sign here to separate our terms. A negative times a negative is a positive. So we'd go plus, and 4 times 5 is 20. So this is the simplified form of that expression. One more. -3 times the 2x would be a -6x. -3 times a +1, negative times a positive is a -3. Once again, you cannot go any further because the first term has a variable and the second term does not. If you didn't have like terms up here in the parentheses, you're not going to have like terms down here after multiplication. Last week we learned how to solve one-step equations. So we're going to review a few of those using some negative numbers, so it's a little bit different than what it looked like last week, before we solve two-step equations. Now remember, when we're solving an equation, something's an equation because there's an equal sign. The things that we were doing before did not have an equal sign unless we put it in afterwards, and so that was an expression, and we were trying to simplify expressions. Here we're solving, which means that we want to find out what's the value for x, that unknown letter, that will make the left side equal or equivalent to the right side. What's going to make that a true statement? So in order to do that, we need to get x by itself. Now equations are balances. The left side is equivalent to the right side. They're balanced. So we have to undo that in the same fashion. Whatever you do to one side, you do to the other side of your equal sign. This only works because there's an equal sign and you have the two sides to simplify. So I want to get x by itself. Right now, I have an x and I'm taking away 6. Well, I want to cancel out that taking away 6, so I want to add 6. Those are called inverse operations. A -6 and a +6 equals 0, and that's gets your x all by itself. Now I can't just add 6 to one side of the equal sign. Remember, this is a balance. If I added something to one side, it would no longer be balanced or equal to each other. So I have to do the same thing to the other side of our equal sign. Simplifying that, we end up with x is equal to, okay, now what do we have? A negative and a positive, one of each sign we subtract and keep the sign of the larger. With a 9 and a 6, I would subtract it in that order. The 9 is negative, so my answer is negative. X equals negative 3. Now the answer is not negative 3. The answer is the equation x equals negative 3. It identifies the variable or your unknown x and its value. So it's a complete statement. It's like instead of just answering yes to a question, answering yes, I believe this is true, or having a complete statement with it. Okay. Next problem says x plus 8 is equal to a negative 6. Same idea here, but since we are adding to cancel out addition, we would have to take away. So if I take away on one side, I have to do the same thing to the other side. 8 minus 8 is 0, and adding 0 to anything doesn't change it, which is why we do it in that fashion. A negative 6 and a negative 8, now in this problem, both of them have the same sign. When they have the same sign, we add and keep the sign. So in this case, x is going to be equal to a negative 14. A couple more examples here of one-step equations that we solved last week. Here we have 6x equals a negative 24. This is not being added or subtracted because there's no symbol of plus or minus between the 6 and the x. So 6x, having that together, means multiplication. To cancel out multiplication, we divide. Once again, if I do something to one side of the equal sign, I have to do the same operation to the other side. 6 divided by 6 is not 0, because 0 times x would be 0. No, anything divided by itself is 1. That's that God of math land. 1 times x is what gives me x. Negative divided by a positive is going to give me a negative 4. Remember, a mismatch is a bad thing, so your answer is negative. One last one here. A little more review with the negatives. Negative 7n is equal to negative 35. Now, yes, it's a negative 7, but between the 7 and the letter, there's nothing there, which means it's multiplication. So to cancel out multiplication, we divide. Anything divided by itself is 1. We don't want a negative n, we want a positive n. So you divide by the entire number, which is the negative 7. The sign goes with when adding or subtracting. The sign goes with when multiplying or dividing. Opposite signs when adding or subtracting. Sign goes with when multiplying or dividing. Whenever you do to one side, you do the exact same thing to the other side. And we get n is equal to negative divided by a negative. Two of the same sign when multiplying or dividing is a good thing, so it's positive 5. So that's a little bit of a review from what we did with solving one-step equations. Now what's going to happen is we're going to put those two steps, those two different types of steps, the dividing and the adding and subtracting, together in one equation and solve the two-step equation. Let's go through some of those. So now we're going to go into two-step equations. Now if you notice here, we have 4t plus 2 is equal to 14. Now I think of an equation as simplifying. If we had the value for t on the left side, we would simplify to see if it checks and equals the right side. And so we would do the 4 times whatever that t value is, because according to our order of operations, multiplication comes first, and then we would add 2, and we're supposed to get 14. Now, if you think of it that way, think of an equation like that as putting together a bolt. Say I'm bolting two pieces of wood together, and I have a hole through there, and I put my bolt through, and then I put the washer on, and then I tighten the nuts on the other side. And to go and tighten my nut, I go righty-tighty. Well, that would be the procedure to putting the bolt on. Now, in this problem, it's the same idea. 4 times t plus 2 would be the procedure of putting the bolt on. The problem is we don't know what t is. We're missing a portion. So I need to undo these steps to find out what size of bolt essentially I started with. Now, if we were taking the bolt off of those two pieces of wood, we don't put the bolt through first. We have to go lefty-loosey on the nut first. It was righty-tighty to tighten it, so you have to go lefty-loosey to loosen it. So you do the opposite of what you did to put it on. And then you do the reverse of pulling the bolt out. So first of all, you put the bolt in and then you tightened. Here, we're going to loosen and then pull the bolt out. You have to do the reverse steps in reverse order. And that's the procedure to solving two-step equations. You have to do it in reverse of what your order of operations is and the opposite step. So instead of righty-tighty, it's lefty-loosey. Okay? So with that being said, you look at a problem like this, 4t plus 2 is equal to 14. If I was simplifying, the last thing I would do is add 2. So that's the first thing I want to get rid of in solving the two-step equation. So to get rid of adding 2, we subtract 2. That's going to give me 4t. The 2's cancel because that equals 0. And 14 minus 2 is 12. Then you do the second step of taking the bolt out as opposed to putting the bolt in. So instead of multiplying, we undo that by dividing. And that's how we get t is equal to 3. Well, that's not so bad. Let's do it again. Let's practice that again. 2x minus 9 is equal to negative 23. If we had a number for x, we do the multiplication, then the subtraction. But because I don't have the letter for x, I need to go and work in reverse. So I'm going to undo this subtraction first by adding. Once again, you have to do the same thing to both sides of your equal sign to keep it balanced. Negative and a positive, one of each sign, we're going to subtract and keep the sign of the larger. And then we divide to get the x by itself. So you get the term with the x on one side of the equal sign and all your other terms, which were like terms, on the other side of the equal sign. And then you divide to conquer. Negative divided by positive is a negative. I have a couple more. Let's practice those. Now this one looks a little bit different because the x is on the right side of the equal sign instead of the left side. That's okay. It doesn't really matter. You still do the same procedure. I'm trying to get the term with the x by itself. So I have to undo the subtraction of 7. If you notice, another way of looking at it is 9 is just a number, 4x is a term with a variable, the negative 7 is just a number. We have to put the just the numbers together on the opposite side of the term with the x. To cancel out subtracting, we add. Now in this case, remember, the goal is to get x by itself. So you always divide by the number in front of x. To get your final answer. One last one. 33 is equal to 5 minus 4x. Now this one has a little bit of a trick to it. Why don't you take a moment and try doing this one yourself. Pause now and then check it when you've come up with an answer. All right, to simplify this one, once again, we need to move the 5 first. Now the sign in front of the term goes with the term. So the 5 is actually a positive 5. So to move it on over, I need to subtract 5. Remember, I'm trying to get this term that has the variable by itself. 33 minus 5 is 28. Now here's my other point though. The sign in front of the term goes with the term. So that 4x is a negative 4x. So you need to have that negative sign in there. Now to get x by itself, we divide. And remember, when we divide, we always divide by that entire number so that I can get x alone. It's a negative 4 divided by a negative 4. That gives me a positive x. Positive divided by negative, mismatch when multiplying or dividing is a bad thing, or negative. So your final answer there is x equals negative 7. Remember, this is a balance. If I have the 28 is equal to negative 4x, it's the same thing as flipping it over and having negative 4x is equal to 28, which is why it's okay to put your variable first when you're putting your answer. It's kind of nice to identify, hey, this is the unknown, and this is what it equals. Make sure you practice this. It's very important that you understand how to solve two-step equations. Do more of them than you need to. And think about your procedure. If you need to write down the steps every single time, do so. You're adding or subtracting first and then dividing to get x alone.